Do you guys have the green sheet? Can you look at the back of the green sheet, the one that's typed, not the one that's handwritten? So you have the numbers 1 squared, 2 squared, 3 squared, right? 4 squared. If you find the answer for these, what would be 1 squared? 2 squared. 2 squared. 4. 3 squared. 9. 4 squared. And 5 squared and whatever, right? So you have, what do we call these numbers? 1, 4, 9, 16. They're called perfect squares because I take a number and I square it to give me that number, okay? So a number is called a perfect square. If one square rooted, the result is a whole number, okay? So on your calculator, what I want you to do is I want you to take your calculator out and I want you to square root 49. Okay? When you square root 49, what are you going to get? 7. How about when you square root 81? 9. How about when you square root 50? You have the calculators, don't you? What's square root of 50? 7.07. Is then this a perfect square? No. Okay? So the minute you put that calculator and you square root, you put that number in the calculator and you square root it and it doesn't give you a whole number, then it's not a perfect square. Okay? So the perfect squares are the ones that you see on the back of your sheet along with the other ones, like, you know, if you do 13 square, what does it give you? 14 square. I didn't have room to give you all of these and there's no reason to give them. Now, we know when a number is squared, right, it's a perfect square. If we square root it, it gives us a whole number. How about a variable? How do we know if a variable is a perfect square? So if I have x to the power of 2, is that a perfect square? Yes. Okay. So x squared is a perfect square. Good. How about x to the power of 3? Okay. How about x to the power of 6? How about x to the power of 9? No. This is not a perfect square. This is not a perfect square. How about x to the power of 4? How about x to the power of 8? How about x to the power of 5? No. So what's common between x squared, x6, x4, x8? They're even exponents. If you have even exponents on the variable, okay, then it is a perfect square. Okay? So that means they're divisible by 2. I can actually divide this by 2. I can divide this by 2. I can divide this by 2, and so on and so forth. Right? So if your variable is divisible, if the exponent on the variable is divisible by 2, it's an even number, then it's a perfect square. And to determine the square root of it, you just have to divide it by 2. Okay? So if I want to know what's the square root of x to the power of 8, right? It will be x to the power of 4. Because what I will do is I take 8 and I divide it by 2. Okay? Square root of x to the power of 10 is? Yeah. Okay? Now, why do we need to know all of this? Why do we need to know when we have a perfect square or when we have a perfect variable, right? Because our lesson that we're talking about right now is called, I don't have it here, difference of squares. What does the word difference mean? So when I say the word difference, if I want to take that and mathematically write it, what is it? Subtract. So I have difference means subtraction. And squares are the perfect squares, okay? So basically what this means, for it to be difference of squares, number one, I need to have two squared terms, and I have to have a minus between them. That's the definition of difference of squares, okay? So in order for me to be able to factor using the difference of squares, I need to do two checks. Check number one is I want to make sure that both terms are perfect squares. So I have to look at the number, and I have to look at the letter and make sure that they are perfect square. Okay? So let's look at this one. I have 9x squared minus 16. Is 9x squared a perfect square? Yes, 9 is a perfect square. If I do square root of 9, that gives me 3. X squared has an even number, even exponent, so yes. Is 16 a perfect square? Yes. Square root of 16 is 4. So perfect. So check mark for this. Yes? The second check mark has to be, do I have a minus between them? Yes. So that's the second check mark. So now I can use my difference of squares factoring technique. Okay? So how does that happen? What steps do I need to take? First, to factor this, you're going to create two brackets. In the first bracket, you're going to put a plus, and in the second bracket in the middle, you're going to put a minus. Okay? I'm going to show you it in 3 steps, but then when we actually do it, we're actually going to do it all together in one step. Okay? So first, you're going to put a plus and a minus in each bracket. Then you're going to square root the first term of the polynomial and place 1 in each bracket in first position. So if I have square root of 9x squared, that's going to give me what? 3x. So I'm going to put 3x in the first position, 3x in the first position in the second bracket. Okay? Again, we will not be doing that when we're solving the question. I'm just showing you technically what you're doing in your head. Okay? For the last step, you're going to square root the second term of the polynomial, and then you're going to put it in the second position in each bracket. What's square root of 16? So my answer, my factored form, is 3x plus 4, 3x minus 4. Okay? Basically, what we're going to be doing to factor, we're going to go from this step to this step. Okay? We're not going to write the steps in the middle. It's just for your brain to process this. Okay? So let's look at the first one. X squared minus 25. The question is factor. That's what would the question be. Factor. What are the questions that you're going to ask yourself? Are they perfect square? Are they perfect square? Is x squared a perfect square? Is 25 a perfect square? Good. Is there a subtraction between them? Yes. So I can do factor difference of squares. So I'm going to create 2 brackets, plus and minus. What do I put in the first one? X. What do I put in the second one? So this is my factored form. Done. Do we understand this? Let's do B together. Is 16x squared a perfect square? Is 1x squared a perfect square? Is there a minus in between them? So, (16x squared) 4x, so the square root of that, basically this is what I'm doing, right? Square root of 1y squared, 1y, and I'm done. Do you notice something? My answers, the 2 brackets, they have the same terms. One is plus, the other one is minus, right? Now if you go back to your homework page 2, homework page 2, did you have anything that looked like this. When you expanded it, it gave you 2 terms only because the middle term turned out to be 0. You had a couple of them, right? I think B was one of them.
Yeah, B was one of them.
Yeah. F.
Well, it's their opposite, like the minus and the plus were different.
Yeah, it doesn't matter. Minus and plus, whatever. But if you look at, there isn't, no, F can't be, wait.
Oh, wait, no.
D, F is not. M. N is not. No. M is. Yep. Okay. Because you had x minus 3 times x plus 3. And then for M, you had x plus 5 times x minus 5. Right? You're going to end up with 2 terms. How many terms did you end up for N? 3. Okay. Factor this one for me. What do you do? Nine x, yeah. 2y squared. Why 2y squared? So you divide that exponent by 2 to give you 2. Yes? Good. Okay. So today we learned common factoring, right? Taking out the greatest common factor, and we learned how to factor difference of squares. The way that you're going to know it's difference of squares is when you're looking and there's 2 terms that are squared with a minus between them. Okay? This is how you're going to know it could be difference of squares. So you guys have to ask yourself the questions, otherwise you won't be able to know which method to do. Because we're going to learn technically 3 methods, but there's going to be one that's mixed. So 4 methods. Okay? You guys have to ask yourself the questions, otherwise you're going to be lost. Okay? So I'm going to stop right now. I want you to start with pages 5 and 6 homework. Do a few of page 5, do a few of page 6, and then I'll see how you guys are doing and then see if I want to do some in product, but I want to make sure that you guys can do this. Okay? Not yet.